Well, welcome to 4.5, our last section in chapter 4. And we're going to do interest rates. This is a pretty short section, but this is really pretty important. And it's very pertinent to percentages. So we talked about percentages, and now we're going to deal with financial literacy and interest rates. Now, a lot of students get confused between interest rate and interest. Interest itself is just simply dollars. So if you borrow $100 and you have to pay back $105 in the end, the $5 is the interest that you paid. It's the fee you're charged for borrowing money. Welcome to the real world, right? Well, an interest rate is a percentage. Notice the word rate, right? Meaning it has units on the top and units on the bottom. So it is a ratio. And an interest rate is interest, which is dollars, right? In this case, it would be $5, divided by the amount borrowed. In this case, it would be $100. And an interest rate is, in this case, 5%. Let me give you another interest rate. Here's an interest rate of 7%. What that means is that for every $100 that you borrow, you have to pay interest of $7. Now, that doesn't mean you borrowed $100. It just means for every 100 that you borrow. So if you borrowed $200, for example, you would pay $14 in interest. Notice the equivalency between those two. So you're not responsible for this, but I want to go over it because it's a good example. So it says you spend $500 using your credit card in December for holiday gifts. On January 1st, you receive $500, a bill for $500, but you only have $25 to pay on that bill. If they charge you an interest rate of 2% each month, how much interest will they charge you on the $475 balance? Now, you're assuming no new charges, right? So that's what you owe, you're carrying on your bill. Now, 2% interest rate means for every $2 you have to pay interest of $2 on every $100 that you spend. That's what it means. And this is a monthly rate. To get the actual, it's called the annual percentage rate, which is the number on your credit card, the rate on your credit card. You'd have to take 2% and multiply it by 12, and you would get 24%. So that's the annual interest rate on your card. So to determine how much you're going to pay for the month, you can do it one of two ways. You can just simply take 2% of 475, which you could also put in like this. Because these are the same. Or you can set up a proportion and say, well, I'm paying for every $100, I'm paying $2 this month on what I owe. Therefore, how much am I paying if I owe $475? So you can set up two ratios and these form a proportion, right? And we can cross multiply 100 times x equals 2 times 475. Divide by 100. Divide by 100. You probably know how to cross multiply, hopefully. And I'm going to get, for both of these, or for all three of them, I'm going to get $9, right? 475 divided by 100 is 4.75 times 2 is 8, 950 it looks like. And I'll check that on my calculator to make sure. So that's what you would pay for the month's interest. So here's the first one you're responsible for, 4.20420A. Okay, so it says you spend $1,800 using your credit card on spring break in Florida. This is post-COVID. Receive a bill for $1,800 and then immediately make a minimum payment of 3% on your balance. What is your minimum payment based on your balance of $1,800? So I am going to do this two ways, right? I owe $1,800 and I make a 3%, or you make a 3% minimum payment. So the two ways of doing that are, you can just say, I want to find 3% of $1,800. And you can certainly just put it in your calculator that way. Or if you like to work with decimals, you could put it in your calculator this way. Now, if you want to do it with the proportion, which is kind of nice in a way because it gets you to really understand what 3% means in terms of interest. So 3% means $3 in interest for every $100 in balance. Interest, balance. And that's proportional to, you don't know how much interest on $1,800 balance. I'll just put a B. So in this case, you would cross multiply and divide. So this method is a little bit longer, but you can see they're all an equivalent way of doing this problem. So, I don't know, I can do this one. 1,800 divided by 100 is 18. 18 times 3 is 54. So that's a nice thing that we learned from before. Same thing here, 18 divided by 100. 1,800 divided by 100 is 18. 18 times 3 is 54. So your minimum payment would be $54. So how much do you owe after you pay the minimum balance? Well, it was $1,800 that you charged, and you paid off $54 before when the bill came due. So it's just that, which is $1,746. So after you made the $54 minimum payment, you now owe $1,746. The APR, which means, and this is an important word, right? It's the annual percentage rate. So an annual percentage rate of 25.6, just to review, means that for every $100 you borrow, you're going to pay $25.60 per year. So if you borrow $300, you would pay 3 times that. You know, these are equivalent fractions. You can look at it that way, which would be 75, 76, 80, I think. but that's just an example. So that's what 25.6% annual percentage rate means. Your monthly interest rate obviously is not going to be as high as this because there's 12 months in a year. So you can just take the 25.6 and divide it by 12 because there's 12 months in a year. And you're going to get a percentage because, you know. And round it to the nearest hundredth, this is 2.13%. So how much interest will be charged for the month of April? And I'm going to again do this two ways. I'm going to be charged $2.13 for every $100 that I borrowed. So how much am I going to be charged if my amount that I borrowed is $17.46? I'm not including the $54 because you paid that on time, so you're not charged interest. So I cross multiply here and I get 2.13 times 1746 equals, cross multiplying, 100 times x, divide both sides by 100, divide both sides by 100, put that in our calculator, put it on pause, and I'm getting 3719. X is 3719, rounded to the nearest penny. And that's dollars, right? So that's how much interest I would be charged on the balance of 1746. Now, of course, another way of doing this, again, now you got to be careful with the decimals, because really the decimal is just 2.13 over 100 times 1746. And I'm, of course, going to get 37.19. But a lot of students like to turn this into a decimal, which is fine, but be careful, right? Dividing by 100 moves the decimal two places. So it's 0.0213 times 1746, and you'll get the same thing. So we only have two more examples left, okay? So using a beginning balance of $1,500 and an APR of $18.24 and a minimum payment of $45, complete the following table. Now here we're assuming that you owe the $1,500 for a month, and so you're going to pay the interest on the balance, and then you're going to make a minimum payment, and then you're going to get a new balance. So we're going to do this for 2 months. So first I'm going to put I owe $1,500 after the first month. So I'm going to put that right there, $1,500. That comes from right here. Now for my interest, this is monthly, right? These are months. This is an annual percentage rate. So I need to find the monthly percentage rate. So there's 12 months in a year, so it's going to be 1.52%. I got on my calculator. So that's my monthly interest rate, which is 1/12, right? Dividing by 12 is the same thing as taking 1/12. 1/12 of the yearly interest is the monthly interest. So this one I'm going to do by finding 1.52% of 1,500, the interest. So I owe 1,500, and I want to find 1.52% of that number. Of course, you can also just do this, 0.0152, which is just this number converted into a decimal. So we need our calculators for this. So when you put it on pause, get out your calculator, make sure you're understanding this. 1,500 times 1.52 divided by 100. And I'm getting $22.80 in interest for the month. So I'm going to put that there. Now my monthly payment is $45. So now I'm going to determine my balance at the end of the first month. So how would you do that? Give it some thought. So I am getting $1,477.80. Now how did I get that? Well, it's $1,500. That's what you owe. The man gets paid his $22.80. But you can take off the $45 that you paid to give you your new balance. Now the new balance, the balance at the end of month 1 is the same as the balance at the beginning of month 2. My interest is not going to be the same because I don't owe as much money. It's going to be a little bit less, right? So my interest here, 1477.80 times, again, my monthly interest rate, 1.52 over 100, and put that in your calculator. 1477.80 times 1.52 divided by 100, and I'm getting $22.46. Again, my monthly payment is going to be $45. That's what I pay. So now I need the balance at the end of month 2. So I would do that by, I'll put the 2246 here. I take 1477.80 and I add to that what I have been charged in interest for borrowing that money. And I'm going to subtract the $45 that I made towards my balance. So that's 1477.80 plus 22.46 minus $45. I'm getting 1455.26. And I'll put that here. And of course this would go on, right? And I think hopefully you can see that this is really best suited, if you're going to run this through, it's best suited to use Excel. Otherwise it's just really time consuming. So this is the flip side. Here, instead of borrowing, you're investing, which means you're putting money into something that's going to give you a return on your money. So you're putting $2,500 in a bond fund. And a bond fund is, bonds are issued by cities, municipalities, townships, states, when they want to make some kind of capital investment. Oftentimes it's very expensive, so they'll issue a bond. Like if you want, your township wanted to have a new water supply for the township, they would issue a bond to pay for it over a longer period of time. And here is the interest rate. Notice that this is an annual percentage rate. And they're going to be giving you interest each year on your investment. Now notice how this works. You invested $2,500. At the end of the first year, you got $155 in interest, and they add the balance and the interest to the new balance. at the beginning of year 2 is the same balance at the end of year 1. In year 2 now you receive more interest because they owed you more money. And so there's your new balance at the end of year 2. And the same thing with year 3. Now for year 4, what is your starting balance? And you should have said, well, it's 29.94.43. So you have 29.94.43. Now, how much interest are you going to get in year 4 based upon your new balance this year of this? And you should say, well, I need to multiply that and find 6.2% of this number, which I can just simply do right here and put that in my calculator. So that's 29.94.43 times 6.2 over 100. And I get 185.65. $185.65. Now I would add these two together. This is my beginning balance at the beginning of year 4. That's how much interest I made during year 4. And I add them together, and this is how much my initial $2,500 bond is now worth after 4 years of investment, which is 2994.43 plus 185.65. And I'm going to have $3,180.08. So that's how much I have at the end of 4 years. Now what goes here at the beginning of the 5th year? And you should answer, well, it's the same as the end of the 4th year. Now I'm going to find the interest I'm going to receive on the amount of money I'm owed for the 5th year. And I can do that 2 ways. I'll do it both. The quickest way, of course, is 3180 times 6.2 over 100. And I get 3180 times 6.2 divided by 100. I'm getting $190.80. So that can't be quite right. 3180.08 first of all. 3180.08 times 6.2 over 100. Always good to check your work, right? I'm getting 197.16. So that's 197.16. The reason I knew it was a mistake because I see it's going between year 3 and 4 went up by $11. And let's start at year 1. At first it's $155 in interest, then it goes up by like $9. Then it goes up by over $10 the next year. Then my interest goes up by almost $11. So it makes sense now it's going to go up by $12. It's not linear. It doesn't go up by the same amount every year because this is compounding the interest, which means that it is growing. 3180.08 plus 197.16. I'm going to add those together. And I'm getting 3377.24. So that's what I would owe. That's what they would owe me at the end of 5 years. Now notice these are years over here. That's why I'm using the APR. I'm not dividing by 12 because these are not months. These are years. So in the next few problems, or last problems of this chapter, I'm going to be doing percent increases and decreases. And sometimes they're going to be multiple. This one's multiple. It's only 2. But here's the problem. You purchase a stock for 50 bucks. The first year it went up 10%, and the second year it went up 8%. What was the value of your stock after the second year? So I worked out the problem here as you might work it out, right? I did this a little different. I could have used 10%, that's 1/10 or 0.1. I could have multiplied by 0.1. It would have been the same thing. 10 over 100, that's 10%, right? So 10% of 50 is $5. So then I added the $5 to the 50, and I got $55. And then I took the $55, found 8% of it, and this is the same, of course, as 8 over 100 as a decimal, got 440, and then added 440 to $55. Now, this is a lot of monkey business. All right, now here's a shorter way of doing it, which I will explain in the next few slides. I could have gone 50 times 1.1 times 1.08. Now take a minute and put that in your calculator and see what you get. And miraculously, yes, you should have gotten $59.40. Now, what are these, and how did I do that? And how did this apply to problems that are even more complicated, but become very simple to calculate and solve? So now we're going to deal with finding the factor that will increase or decrease a number by a given percent. And I call this the 1 plus or minus the rate idea. If you're going to increase it, you're going to add. If you're going to decrease, you're going to subtract. So I'm going to show you how this is going to work. And I'm also going to do these problems here. So we're going to increase something by 5.4%. I'm going to use 1 plus or minus r, and then I'm going to put that in my calculator and get the factor. And the factor is the number I will multiply by in order to accomplish my task. My task starts out at 5. I want to increase a number by 5.4%. That means I want the number and 5.4%. So that is 1 plus 5.4 over 100. Because that's what 5.4% means. And so the factor, if I put this in my calculator, I'm going to get 1.054. So the second one is I'm going to increase a number by 120%. Now this is no different. I want the number back plus 120 over 100. So 120, I'm going to put this in my calculator, and I'm going to get, this is 1.2, so I'm going to get 2.2. Now if I were to ask you, for instance, to take the number 50, and we did this in the last slide, and increase it by 10%, and I'm just going to put that in here, right? Increase it by 10%. That would be 1 plus 10 over 100. Put that in my calculator, and I get 1.1. So let's look at this, which I did in the last slide. Now 1.1 is 1 plus, right, 0.1. because the way numbers are constructed, right? And from the distributive property, 50 times 1 gives me the number 50, plus 50 times 0.1 gives me 5. And in one fall swoop, I would get 55. So this is what's going on here in all these problems. So now let me decrease a number by 15%, and finally decrease a number by 10.2%. And I advise you not to jump to this step here, to the factor. The factor is the number you multiply by in order to achieve whatever task here you're trying to achieve. So this is 1 minus 15 over 100. And if you put that in your calculator, you're going to get 0.85. Notice this number is less than 1. And when you multiply a number by something less than 1, you're going to decrease the original number. The opposite is true up here, right? These are more than 1. So the last one is 1 minus 10.2 over 100. I want you put that in your calculator and see what you get. And I'll give you a little bit of time, or put it on pause. And you should get 0.898. Now recall that what we're doing here, right? If you want to decrease a number, say take any number, let's take 90, and you want to decrease it by 15%, you would multiply it by the factor 0.85. And I would get 76.5. That's 90 decreased by 15%. So this is just a little bit of information which you don't really have to memorize, but it's one of the main areas that we use percent increases, right? The CPI is a measure of the average basket of goods. It's a basket of consumer goods over time. So it's not like an Easter basket, right? But it would be like things like a car, repairs on a car, bread, TV, or your iPhone, computers, vegetables, meats, all kinds of consumers' goods. And these are broken into some categories like transportation, recreation, all these different categories. And this goes back to this date here, which is hard to see, but this is what it cost. This average basket of goods looks like it costs about $140. And over time, it's increasing. So it increased maybe by 1%, 1%, 2%, 2%. Here it increased by quite a bit. And you can see that the entire basket now costs over $200. That same basket that cost $140 now cost over $200. And actually, for your generation, the last generation, the growth in inflation has been pretty tame. And they want to keep the growth. You want to have some growth. You don't want too much, but you want some. And the Fed target is about 2% per year of inflation, an increase in the basket of goods. Japan's experiencing deflationary pressure. This means that prices often decrease year to year. Now think about that. This hurts economic growth as customers are reluctant to purchase items if they're going to cost less in the future. So why buy a car this year if it's going to cost less next year? Assume a basket of goods costs $500 in the year 2015. So this is our basket of goods in Japan. And we're going to use dollars instead of yen, even though yen is, we're going to put it in our money. Just $500 in 2015. And we're going to look at this as this basket of goods went up over these years. So in 2016, it went down by 0.12%, 17, up by 0.47, up by 0.89, down by 0.48. So it was a little bit of a mixed bag in terms of going up and down. But overall, in the last 20 years, it's actually gone down. So let's look at how we would do this problem with our newfound knowledge. So we're going to determine what the price of goods was, the same basket of goods that in 2015 cost $500. We're going to find out what it costs in 2019. So going down by 1.12%, this was going to be 1 minus 0.12 over 100. And I'm just going to write these out. This is going to be 1 plus 0.47 over 100. Right? This is 0.47%. A percent means how many per 100. This is 0.47 per 100. This is going to be 1 plus 0.98 per 100. And this is going to be 1 minus 0.48 over 100. Now I want you to put this on pause and do this work here and find the factors here from here. The factors are what we're going to multiply 500 by in order to get our answer. The answer being, what if a basket of goods cost $500 in Japan in 2015? How much did it cost in 2019? Based upon these rates of inflation or deflation. Okay, so I got all the numbers there. Hopefully they match what you did. And now I'm just going to do the problem. So here's the initial $500. The first year it went down by 1.2%, so I'm going to multiply it by 0.9988. That's what I got there. And I'm not going to stop. I'm just going to, this number right here is 500 down 0.12%. So I can just multiply by the next number, which is 1.0047. And then 1.0098, and then 0.9952. Just like that. And when you put it on pause again, check at your calculator, make sure we get the same result. And rounding to 2 decimals, I get 504.23. So the basket of goods that cost $500 in 2015 in Japan, that same basket of goods in 2019 cost $504.23. It's not exactly deflation for these 4-year period, but it's a very, very small increase in inflation. But that's how you use these factors. This problem is actually very easy to solve using our new technique of repeated factors. It says a stock valued at $200 increases in value by 10% for 5 years in a row, and then decreases in value by 10% for each of the next 5 years. What was the stock worth after the 10-year period? Well, maybe your intuition will say, well, if it goes down by 10% for 5 years and then goes up by 10% for 5 years, then it's going to wind up to be the same as it started. That tuition is not going to work. All right, the reason is, one of the reasons is that if it goes down by up by 10% the first year. The second year it goes up by the new value. So it's not going up by a constant number or going down by a constant number. But let's look at 1 plus or minus r to figure out our two factors. Our first factor is 1 plus 10 over 100, which is, the factor is 1.1. And the other is 1 minus 10 over 100, and the factor is 0.9. Now, is there an easy, I'm just going to do one little side thing. Is there an easier way of writing this? Is there an easier way of writing that? And if you answer yes, x to the fourth, that would be a simpler form, right? So I'm going to use this idea here. So I'm going to start with 200. I'm going to increase it by 10% 5 times. 1, 2, 3, 4, 5. And then I'm going to multiply it by 0.9, the factor, 5 times. So definitely put this on pause and put it in your calculator. But look how easy this problem is compared to maybe even 20 minutes ago or 15 minutes ago. When you had to do this, it'd take forever. And you should get 190.20. Counterintuitive, but look how simple it is to do. Okay, so these are to get you started on some homework problems. And I will, of course, post the homework problems after the assignment is due, so you can check them. So it says compute the monthly interest rate if the APR, and that's, first of all, interest rate is a percentage. You go look at any interest for your car, your house, anything that you're going to buy in the future, and it's going to give you, you're going to find the interest rate, and it's going to also give you the APR, which is the annual percentage rate. That's the annual rate. You're certainly not going to pay 26.9% monthly. We're trying to calculate the monthly rate, but it is going to be a percentage. This is like a credit card. 26.9 divided by 12. The daily interest rate is going to be a lot smaller than the annual percentage rate. And there's 365 days in a year. 26, and by the way, the answer here, just by doing this, is a percentage. Because this is a percentage. This is the same thing, but there's 365 days in a year. So see if you can figure these out. This is going the other way. I'm going to find the annual rate if the monthly rate is 0.98%. Well, if the monthly rate is 0.98%, and I'm trying to find the annual, I would multiply it by 12. And that's going to be a percentage, and it's going to give you the APR. And you can figure this out by going backwards from number 2. Okay, I'm going to start this table for you. And this table is, here's the starting balance. The periodic rate is going to be how much do you pay each period. And you're going to pay this, you're paying this off monthly, right? So the periodic rate is going to be 26.9 divided by 12. And that's a percentage, which means part of 100. So you want to find the interest for the first month. And you would do that by taking 2,900 and multiplying it by this rate here. And then you would add those two, because this is what you have to pay the bank for the privilege of borrowing the money. So you take your balance, add your interest, but then you subtract your payment. And then you get a new balance. And the balance at the beginning of month 2 is the same as the balance at the end of month 1. And that's how you run this down. Obviously, this would be much better for an Excel spreadsheet. So it says here the Pfizer stock was priced at $44.25 a share. It pays 43 cents in dividends per share every quarter. What is the annual percentage rate? This is a little tricky, but what this is, you're getting 43 cents 4 times a year, because there's 4 quarters in a year. And that's divided by the amount at the share cost. And you take that and you want to find that over 100, which is a percentage. And then you would get the percentage. So you paid $370, a $375 payday loan in 1 month. You were charged $80 in interest. $80 in interest for the 1 month out of a total of $375 equals some number over 100. Here's your percent. But that's for 1 month. You want the APR. So whatever you get here, you have to multiply it by, you're right. These I did these exclusively in the lesson. So you can figure these out, and I will put the answers up after this is done. This is a good one for you to explore. Alright, this is the one I did too. The thing you want to remember here is the first thing you want to do is find the factor that is going to increase this $5,000 by 7.2%. Use 1 plus or minus R. You use that to find the factor. And you're going to raise it to the 5th power, right? This one is going to be 1 minus 14 over 100. That's 1 minus R. So what's that going to be? 0.86. So that's the factor you're going to use in order to do this problem. These are really good problems.